Alright, so today we're going to work on optimization problems. And so in this scenario here, a farmer wishes to create a rectangular enclosure ABCD. The total area of this enclosure is 525 meters squared, as shown below. The fencing used for side AB, so this is going to be $11 per meter, and this is going to be $3 per meter, $3, and $3. And so I need to create a cost function C of x if x is AB. So that means this length here is x, which also implies that this is x. And so, well, I don't know what this is, so let's call it y. And so I know I want to find the cost function. Well, if I consider that, my cost function is going to be, if I find my cost, it's going to be, well, 11x plus 3y and 3y, 6y, plus 3 more x. So the cost is going to be 14x plus 6y. So now I have a problem though, because this is a function of x. I have a y in my function. And so oftentimes with optimization questions, you're going to have a quantity like cost that we're trying to optimize related to variables. And we need to get rid of one of the variables. And so we have to find a relationship that deals with these two variables so we can eliminate it. And what we know is that the area is 525. And so I know that xy is equal to 525. And so y then is equal to 525 over x. And I can plug that in for y. And so the cost function is going to be 14x plus 6 times 525 over x. Okay, and so that is my cost function. And so if I simplify that, I know that C of x is equal to 14x plus 3150 over x. A part done. B part now says find the derivative. Well, that's the easy part. 14x becomes 14. And if I recognize that this is really 3150x to the minus 1. So the minus 1 comes down, and it's x to the minus 2. So here's the derivative. And then hence find the minimum cost in the dimensions of the enclosure. Well, so now if I'm going to consider this, if it's going to be a minimum, that means this equals 0. And so I can say that 3150 over x squared, moving this over, is equal to positive 14. And so 3150 is equal to 14x squared. And 3150 divided by 14 is x squared is equal to 225. And so x is equal to 15. All right, so x is 15. And so if I want to find my cost, my minimum cost in the dimensions, well, the dimensions, if x equals 15, I can use my area to find the y value. So y I know is 525 over 15 now. And 525 divided by 15 will be 35. So my dimensions are 35 by 15 was my rectangle meters. And my cost is going to be 15 into the 14 into my cost function here. 14 times 15 plus the 3150 over x. And if I work that out, I get 420. And so the minimum cost is 420 when the dimensions are 35 by 15. And so in doing these optimization problems, it is quite the most common scenario that come across is you have to minimize a quantity, and it usually comes in 2 or 3 other variables, You have to find some relationship to eliminate the variables so that you can get like c as a function of x, and so on.